Hello everyone, my name is Devashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions, and I welcome you all to this special webinar today. And today's topic is Cisco Route Map Filtering. So we will discuss what is the difference between the access control list and the route map. What is the power of the route map in, say, filtering the network traffic, in managing the traffic flow. So let's begin. So we'll discuss the Cisco route map filtering. First of all, we'll understand what is a route map and an overview of mechanism and techniques for effective routing for the route map. That is our agenda today. So route map is a very powerful utility and it is like a Cisco ACL. But yes, to explore the Cisco route map filtering, we must focus on the definition, components and practical applications. So what is the definition? So the route map is there like the access control method, just like the ACL, but it is more powerful than the ACL. It is a very powerful ACL, you can say, because in case of ACL, you can do what you can just permit or deny some network traffic from outside or inside your network. But route map goes beyond that. Say for example, say you are redistributing between the routing protocols, then it can also filter the routing updates or some, say, some type 7 LSA, type 5 LSA. It can block from the OSPF or from any protocol. Say EIGRP, you are running an autonomous system and you want to advertise the loopback interfaces on one router. You are advertising, let's say, 5 interfaces, and you want only one interface update will go to the other router and other updates will be blocked, they'll be denied. So you can do that. You can filter the network prefixes, you can filter the updates there, but with the ACL you cannot do it. ACL you can only permit or block the entire network or one PC, but here you can do many things. Even you can change the metric values also. Say, is it the very high level like the BGP configuration? We can also do many things in the route map, and route map is heavily used in the border gateway protocol, but yes, we can use in other protocols as well. So later I will show you the practical implementation also in the GNS3. But first, let's get an overview of the route map. So what is the definition and purpose? Like, the route map is a powerful tool in Cisco networking that I have already told you. It enables network administrators to control the traffic flow and apply policies to routing updates. Yes, if you want to do the traffic engineering, like you want to, say, change the traffic flow, say the best path selection of the, say, BGP or any other protocol, you can implement route map to effectively change the route policies. The primary purpose of route maps is to filter routes, modify routing information and influence routing decisions. So let's say there are many path attributes in the BGP, like the weight, local preference, MED, different types are there. So you can actually configure route maps for that, for influencing the path selection process. And also you can do it in other protocols also, but route map is heavily used, as I've told you, in case of BGP protocol. Then what are the components of route maps? Route maps consist of several key components, like the number one is a statement, which define the conditions for matching the routes. So you have to make an ACL first. So if you want to allow some routes or some updates or some network prefixes, as we say, you have to do it with ACL. That is the first thing. Number two, match criteria. So you have to do a match statement. So it is matching, say, either a ACL, which determines specifics like IP address or protocol. IP address means the ACL, and protocol means if you're matching a particular routing protocol. Number three is set actions. So which specify what to do with match routes, such as, say, alerting the metric or tagging the route. So you can tag the route also. Say for example, in case of OSPF, we can tag it with, say, the E1 or E2 route, the external 1 or external 2 route. So these things you can also do. And set action is not mandatory, but match should be there. You have to match a particular criteria, and then set means that against that match, you can tag the route, you can change the metric of that route. That is the thing. Types of route maps. So there are two primary types of route maps. Number one is standard route map. Say it applies conditions based solely on source IP address or prefix. So when the traffic is coming from a network with the source address, that is, it filters the source IP address. It is like, you can say, the standard ACL. Number two, extended route maps. which offer advanced filtering options by considering additional parameters such as, say, protocol. You can consider attributes like the path attributes I was talking about in case of BGP and more. So these are the extended route maps, like the extended ACL, you can say. And each type is used depending on the specific routing policy. So what are the filtering techniques here? Number one is match condition. So match condition in route maps, it is used to determine whether route matches a specific policy. So if there is a condition, let's say two loopbacks 1.0, say 1110 and 1120, these are the two networks that should be advertised to the neighbor router, say in case of EIGRP or OSPF or BGP. Then you have to match those networks first, and the network prefix or the subnet mask or the side value, especially in case of BGP, should be very unique. It should be exact match. Now it can include IP address matching, protocol identification, and say the policies like the access list. And by setting these conditions, administrators can definitely select filter routes based on some defined standards. Number two is set actions. Now, one is match, then the set, but set is optional. Set actions dictate what happens to match routes. So common set actions may include changing the route's admin distance, so that is the traffic engineering, path manipulation, modifying the metric, or tagging the route for further processing. So these things can be achieved if you do the set statement. But if you do not do the set statement also, you can achieve it, because the route filtering can be done with match statement itself. These actions allow for fine tuning of routing behavior. What are the common use cases for the route maps? Route map filtering is frequently used to manage traffic, that is the traffic engineering, control the route redistribution. So when you are, say, redistributing means when you are connecting to different protocols, say EIGRP to OSPF, OSPF to BGP, these things among different routing protocols, and apply QoS, quality of service. Yes, that is a very important thing. Like when you are actually managing the congestion management in the router. So in that case, route maps can be used to configure the QoS, and it enhances network performance and reliability by ensuring only desired routing information is processed. So if you want that one information to be suppressed, you can do it with the route map. So we can conclude that Cisco route map filtering, it is an essential feature for network management definitely, and it allows for detailed control over routing decisions and path manipulation, because the traffic engineering is a part of our network decisions nowadays, and we must understand this type of route maps filtering techniques and their applications. And by doing that, administrators can effectively optimize network performance security. So there is no question on that. So if you are actually selecting a path, say there are paths to the two different ISPs, or there are two paths to the same ISP. So which path to take, which path the data should take. So for that, you have to do the path manipulation, and for that, route maps can be used. So this is about the general overview and the theoretical discussion about the route maps. And now I will take you to the GNS3 console, because in the packet tracer it is not available. The packet tracer only supports the Cisco ACL but not the route map. So we have a very simple setup here with two routers, R1 and R2. Let's start those. And the routers are starting, and then just configure the IP between them and also the loopback, say on the R1, and then start the EIGRP process. So all the loopbacks will be advertised to the R2, the neighbor. Now we will implement the route map, and we'll implement the distributed list also to actually send the route map to the R2. We will filter or block some routes. So let's give the IP first. Say 1001. And also you go to the console of the R2. Now in the R1, say interface loopback 0, IP address say 10.0.1.1, and 255.255.255.0 because I want that the network ID should be up to the third octet. Interface loopback 1, then say IP address is 10.0.2.1, so that is a different network, and again say loopback 2, 10.0.3.1, this time another network. So these all are the loopbacks, and then you configure EIGRP. Router EIGRP, then the AS number, let's say it's 1, and advertise all the interfaces, say network 0.0.0.0. Otherwise, you have to go for each interface. Then you go to the R2, router EIGRP, and then the process ID. And so let's say the AS number is 1, and the network is 0.0.0.0. So the adjacency has come up in the case of EIGRP, and if you see the show IP route, you will see all the loopbacks that is advertised, or show IP route, then EIGRP. You can see the 10.0.1.0, 2.0, 3.0, all are advertised. But I want to suppress, to filter this 10.0.1.0 network. So this will not come. So what to do? So in that case, you have to create a route map. So let's do that. Or let's say on other hand, let's say I want to allow only 10.0.1.0, that would be better. I will permit that, and 2.0 and 3.0, that would be denied, means that would be suppressed. Only 1.0 will be allowed, and 2 and 3 will be suppressed. So create an ACL. So this say 10 or anything, and you permit the network that is 10.0.1.0, and you specify the wildcard mask, that is 0, 0, 0 and 255, because it was using the class C default mask 255, 255, 255 and 0. This one. Now create a route map. Route map, say test 3, something like that, and then permit, you are permitting that, and then the route map will use a number, that is a sequence number, as you can see. So say permit 10. Then match clause, match. If I give the question mark, you can see all things there. It can match AS path, it can match IP, it can match IP basics, metric, many things. I'm matching now the ACL, that would be the IP, match IP, and the ACL name, that is the access list, say the 10, match IP 10. Or I should give the IP address, I think. Okay. Now it is matching the 10.0.1.0. And now do not allow or do not permit others, because otherwise the 10.01, 10.02 and 10.03 all will be permitted. So in this case of route map, this is very important to do it sequentially or do it wisely. We are only going to permit this. So route map test 33 or something, permit 10, and you just matching the IP address, means not only IP but IP address means here the ACL number is pointing to the ACL 10, which is permitting 10.0.1.0, and I will just end here the route map. I will not write the, say, the route map test 33 and permit, and then the 20, permit 20, like that. Means I am not matching the other lines. I'm not matching the other prefixes. If you write that, then all the prefixes will be matched. Like that, if I write here, then route map test 33, then permit, then the line 20, it means if I press enter, all the routes are permitted. means other routes are also permitted. I am not going to give that. And now let's go to the router EIGRP, and the A is number 1, means it was EHS number 1 indeed here. And let's do a distribute list filtering. Distribute list, give question mark, and you can give a number or you can give a route map. I'm giving a route map. Say the name is test C3, and the direction you can give question mark. The direction is in for the incoming filtering or out for outgoing filtering. So I am giving out because I want this filter to be applied to the R2, means it will only allow 10.0.1.0 network. So I've given it to the R2, and now go to R2. And yes, you can see the message has come that EIGRP is saying from the neighbor 1001, it has received a route map. It is racing. Peer graceful restart means it is resynchronizing its routing table. And now let's verify with show IP route EIGRP in the R2. You can see here I only have 10.0.1.0. Previously, you could have the show IP route EIGRP 10.0.1.0, 10.0.2.0, and 10.0.3.0. But now you do not have that. You have only 10.0.1.0 because I have permitted only that. So that is why this is like the filtering. We are suppressing other networks. We are suppressing the 10.0, 2.0 and 10.0, 3.0. So these are like the route map filtering. We can filter in many ways. This is a very normal filtering or very easy filtering, you can say, that I've shown you. Or else you can redistribute also, like you can redistribute the static routes or the connected, directly connected routes, or some say OSPF and EIGRP, both protocols are running, and then you should have an say ASBR, autonomous system boundary router, to do the redistribution between the routing protocols, and you can do the say the route map filtering on the ASBR. You can do it. There could be many scenarios where you are stopping the routing updates or the prefixes from one routing protocol to the other. So these would be more complex things, but definitely this is the base. So you can, I think, easily understand what is the power of the route maps. Because if you say go to the route map again, I can show you one thing more. Route map, and say give any name, say CCNP or something, and you can either give deny or permit. But in case of ACL, you have to always write access list permit, means you are permitting this entry in the ACL. And here in the route map, you can either use permit, so you are permitting that, or you can use deny. So permit means that I have here done that 1.0 like that 1.0.1.0 network, that should be permitted and others should be denied. But if you give here deny, then the opposite will happen. Then whatever you are specifying in the ACL, that would be denied, and you have to explicitly give this permit statement. That permit statement, that route map name, and the permits a line number 20. So otherwise everything will be denied. So this sequence is very, very important. And already I have shown you the match statements also. In case of the route map, it can match many things. It is a community, means the BGP community. You can see that a lot of BGP things are there in this route map. Also we can do other things also, like the IPv6 or the metric, and metric is specified is in case of route map. Like if I'm redistributing and I'm changing the metrics of say the OSPF protocol, say some external one routes is entering into the other routing protocol, routing domain, and then you are increasing the metric or like that, that also you can do. You can change the route type from the say external 1 to external 2, E1 to E2 routes. That can also be done in the metric. So there are many functions there in case of the OSPF and BGP protocols, that is also can be explored with this route map. So route map is a very powerful utility that you can see in the router level, and it is far beyond the ACL. ACL only restricted to that I've shown you, like permitting or deny the network or a single host, say to from one network to the other, or the standard ACL that filters only on based of the source IP address. But route map is far beyond. It is actually manipulating the route. It is actually doing the path manipulation of the traffic engineering. So it is a very powerful utility, and BGP solely relies mainly on the route map filtering. So in case of BGP, we do not have other commands. We cannot specify the ACL or other commands to do the traffic engineering, but we use the route maps mainly. And the some routers do not support the route maps, like the older ones, like you can say the very old ones, say 2500 like routers, you may not find the route map, and those routers are already like the obsolete. But in modern any routers, and also in the present the ASR, all these routers, they definitely support the route map utility. But route map you can do it only in case of the GNS3 or the EVNG simulator, and on real Cisco gears, not on the packet tracer. So that is about the Cisco route map filtering that I've discussed with you, and in very detail also I've told you what is the power of the route map, why you use that, and also I've shown you practically also by configuring a basic route map that will definitely make you understand the concept of the route map, I think. So route map is very important for the study of the mainly the CCNP. It is important for CCNP, but yes, it can be also studied for the CCNA also, because you should have some more knowledge about the CCNA 200301, not only for the ACL but also for route map. And for enterprise, CCNP enterprise and CCIE examinations, route map is absolutely essential for you. Without this, you cannot learn the BGP or ISIS or any other advanced protocols, or OSPF, say the LSA type filtering. You cannot say filter any type 4, type 5, type 7, type 3 LSA. You cannot filter anything. So this is about the Cisco route maps power, and I think we'll explore it more and more in future. And it is very important for your studies, for your Cisco certification. Also, as a network engineer for traffic engineering, this route map has no other choice. So this is a one thing that you should master very well. So I hope that it was helpful for your Cisco studies and also for job prospect. And from this webinar, you have gained a lot of experience and a lot of knowledge you have gathered. And also you can incorporate this knowledge for a certification purpose, and also in the real life environment in configuring the networks. So that is about the Cisco route map filtering topic for now I have. I'll come with some new topic next time. Till then, keep studying and bye.